comments of just sort of main points from the day. And I would like to take a minute to acknowledge some of the astute comments that were shared in that chat yesterday. First of all, the comments mentioned general tools with broad applications, how AI-enabled advances bridge the physical-digital barrier. So implicit in many of the comments were the strengths of AI and the advances this can bring, that, you know, the huge benefits that this brings to science. So these you know, these provide huge benefits, the broad applications, the bridging, but of course they can be associated with risks, and this is what we are here to think about today. So yesterday in those waterfall comments, one commenter suggested that we think qualitatively rather than quantitatively about risk. Another asked whether we can identify where the best choke points are for mitigation. But then there were several questions around which stakeholders are responsible for evaluating and potentially mitigating the risks of disseminating across the many diverse outputs that we now have for in silico research in biological systems. So I think that sets up, you know, many questions still, and a lot of discussion that can happen today. And so I'm going to turn it over to Alex to give an overview of today's goals, building on yesterday's discussion.
Great. Thank you very much, Valda. I'm Alex John London. Thank you for joining us. For those of you who are joining us for the first time this week, I'm co-chair of this planning committee with Valda. I'm the K. Gates Professor of Ethics and Computational Technologies at Carnegie Mellon University. This is a slide that I showed yesterday that tries to capture the questions that are in scope for our meeting. And yesterday we talked about the various outputs and resources that are associated with in silico research in biology, the various venues or outlets in which those outputs can be disseminated, and the challenges of identifying and quantifying or categorizing the biosecurity concerns that can result from the dissemination of these results. So today we'll continue that discussion with a renewed focus on two areas. First, the diverse outputs of in silico research and the diverse venues in which those outputs are disseminated entail that a wide range of stakeholders now play a pivotal role in the dissemination process. And as a result, they may now have obligations to promote scientific integrity and mitigate biosecurity risks. And then second, what approaches or strategies might these different stakeholders use to promote high-quality science and scientific progress and the openness of science while mitigating the biosecurity risks associated with disseminating in silico research in biological systems? So in an effort to link the conversation of these 2 days together, I have some reflections from yesterday to try to facilitate our thinking for today. And the first is that many stakeholders have a common set of goals that entail a common set of objectives. They want to reduce biosecurity risks from the dissemination of research outputs while preserving various aspects of the integrity of science, the openness of science, and the benefits of these outputs. So the goal here is to find strategies that will allow us to move to this optimal balance here between the openness of science while mitigating biosecurity risks. Additionally, we have heard yesterday from several speakers about the need to preserve a strong presumption in favor of open science. So this wedge is an attempt to represent the idea that all in silico research might have some dual use potential, but that most in silico research in biology has relatively low biosecurity risk. So if we try to import into the in silico context the biosecurity frameworks that were developed for physical research, then we're committed to trying to identify a threshold at which dual use potential in research rises to a level where biosecurity risk management and mitigation practices are warranted. And so on this approach, the idea is that DIRC are a subset of heightened biosecurity risks. And we talked yesterday about whether there are other biosecurity risks in this context that also merit mitigation or management. That model is in a bit of tension with a related but distinct way of thinking about these issues. This would be the idea that such a strict threshold isn't particularly helpful because many stakeholders have obligations to be vigilant about the dual use potential of in silico research, and there might be a wide range of steps that those stakeholders can take to manage or mitigate those risks, many of which are not very onerous. So on this alternative model, what changes is that as biosecurity risks increase, the moral responsibility of stakeholders to address those risks would take on greater responsibility to provide public assurance that those risks have been properly mitigated and managed. And so today, we'll focus on various methods that might be used to promote high quality science and scientific progress and the openness of science while trying to do just that, trying to mitigate the biosecurity risks associated with dissemination of in silico research in biological systems. And an interesting question then is whether these two approaches can be combined in a way that maintains this optimal balance between these various objectives. So here's the agenda for today. And in our first session, we'll have the opportunity to consider lessons learned from other technologies and other research domains across diverse sectors and how some of the stakeholders there have tried to safeguard the integrity and the benefits of science while managing and mitigating associated risks. And so to start the day, it's my pleasure to hand the floor to Amina Kutab. Try the other mic because that one.
Does the online audience hear me? Okay.
Okay, now I can hear you. I couldn't hear you before. Thanks, Amina.
Okay, no worries. So let me just give a brief background on what I just said. So I want to just say that Diane's going to speak first, and then we have Ken Oye from MIT. So Diane, please go ahead. Thank you.
Okay, great. Thank you so much. Sorry about that little snafu. I heard everything up until it was your turn, Amina, so I apologize for that. Well, good afternoon, everybody. Thank you so much for inviting me. And I was able to listen in to some of the earlier portions yesterday, and I think there's been some really fantastic discussions going on. I hope that I can help you guys kick off your deliberations today with some words of wisdom that haven't already been said by people during this meeting. This is obviously a really timely and relevant topic, and I think that the deliberations that you're taking are going to really add some important options for understanding risk in this space and how we might mitigate it. So I just want to start with an overall comment about the policy and governance landscape. And some of you may be familiar with research that I have done with Kavita Berger and others that included a look across all the legislation, governance, policies, guidance ad nauseum in the bio community, going back really to the original invention. And one observation that you can make across this 100-year expanse is that our policy in the bio realm has been reactive in nature. And that is, as new disruptive and converging advances have occurred, we've iteratively responded by adjusting our policy or creating new policy in response. And as well, if something bad happened, we have also reactively created policy in response to try to prevent that bad, unexpected thing going into the future. So it may not have been the best approach, but it's been an approach that was erring on the side of openness to ensure innovation and progress in the life sciences. And so in some ways, I have likened this to creating many small hurdles to the harmful use of biotechnology, that is death by 1,000 paper cuts to a potentially bad actor. In other words, there's too many things I have to traverse to try and use biology for harm, so I'm just not going to. So I think we can agree that this has worked fairly well over the years. We've gone through many numerous disruptive emerging technologies that have punctuated the otherwise iterative progress of biotech over the past several decades. So when it comes to informational risk, which is key to much of what you're talking about yesterday and today, one thing we can say is that we have been here before. And I think it was mentioned yesterday, straight out of the introduction by Gigi, the original Fouchier and Kawaoka papers that provided information on H1N1 virulence sequences were essentially information risks. So those of us who were involved in the creation of policy around that time, we did focus on the upstream research pathway where there was policy lacking that led to the culmination of these papers, which was policy for dual use research of concern and gain of function. And although I know the research pathway itself is out of scope for your purposes, I'd encourage you to think about information risk mitigations that still could be applied upstream. So for example, prior to the release of particular AI tools or models, computational models, automated tools, what should be happening prior to unleashing those kinds of things, and what might those be? But getting back to the H1N1 policy time, there were some important changes that those papers initiated, namely the kinds of biosecurity reviews of research that might have information leading to the development of bioweapons. And so now, almost 15 years later, we think of this as fairly routine, which I would consider to be a success story in some sense. Many of us do the security reviews, as a matter of fact, in reviewing papers for journals. It was discussed yesterday a bit. But I think also as part of this, we've made the community much more generally aware and thinking about information hazards in particular areas of research prior to publication in journals. And I think that Ken may say more about some of those earlier deliberations and what we learned from them that was valuable. Now, of course, we are going beyond publications to this wider array of in silico media, and the risk space is broader and it's multidimensional. But I think there are two things in my mind that are true when we think about policy and governance in this space. First is that if it is publicly available in silico, regardless of the type of information that it is, whether it's a preprint or a YouTube video or a Substack article, it's going to be available to AI. I think Roger Brent said it yesterday, and I will echo his thoughts on that, is that if it's publicly available, AI will begin as data. And the advantage of AI is that it can gather complex information rapidly in narrative fashion from all of these in silico sources and kind of present it when a question is asked. I know that this isn't all about AI, but we can't ignore that AI can change the dial to information that could be used for harm. And we need to think about the ways that it's doing that. Is it better or worse than a traditional Google search for someone who's looking for information on things? And information, no matter how complex or sophisticated it is, the second point I want to make, that this information doesn't equal biological hazard. You had some lengthy discussion about this yesterday. It has the potential for use to lead to harm, but it in of itself, the information isn't the hazard. So that, I think, despite some successes from the original papers that kicked off some of these dialogues, that puts us in a really challenging policy place. At some point, there is a kinetic inflection point where the biological thing is created and used for harm. Linda Stewart talked about this yesterday, in that there's still a need for the physical wet lab portions. I think her idea regarding this if-then statements about where we could understand when the need for wet lab validation is no longer there, that's going to be a really important contribution to understanding changes in that kinetic inflection point. Is that sliding along some scale? And how do we understand that in the context of risk? I think the biggest challenge that you all may have in this space, that we all have as security folks, is how do we evaluate the risk that's changing the kinetic inflection point? Number one, we could ask, is there any line that we can draw from the get-go that says this risk is unacceptable, this information definitely leads to harm in any iteration, and should categorically not be shared in any public format? Now, in the biological sciences, that's really hard. There aren't too many examples of things like that we could say. Maybe there is in this space, but I find that to be challenging in life sciences. So that means we have to further define the risk. Jim Diggins said this yesterday. He has said it before. I have referred to that in some papers I've written. I completely agree that we need to answer the question, what is it that we want to protect from the bad thing that we want to protect from happening? And by what type of actor, right? That could be, want to do that, and work our way backwards to say, how are we going to prevent that from happening? So in addition to this, general information risks, which we've been concerned about for a while, we're talking about some powerful capabilities in terms of computational modeling, in the actual design and manipulation of biology. And so really, what tools do we have in this space? I'd like to ask just kind of a couple of questions. In addition to, is there a red line that we can draw? I'm guessing that there aren't too many red lines we can draw. But first and foremost, what is in our policy toolbox now? Do we have good practices right now that can translate to anything that we are concerned about? A second question that I have here, what kinds of data from these models are actually available to which kinds of actors? For some of these more complicated and complex modeling capabilities, I have been, in my mind anyway, categorizing these somewhat differently than just large learning models, AIs that can just generate information. But the actual use of models and some of these complex algorithms and computational things, are they under IP restrictions? Are they protected in any way? Are they patented? What kinds of restrictions might people have in the intellectual property space that we could leverage and lend themselves to policies that discourage broader employment into the hands of people that maybe should not have access to those kinds of things? That's a question I have. A third question would be, are there any tools that could separate qualified from unqualified users? We had this conversation back during the H1N1 deliberations. And again, I think Gigi mentioned some of this yesterday, and I will echo that, is that we found some ways to share mutations in H5N1 with the research community that were considered to be safer than just kind of throwing them out there broadly to everyone on a kind of a need-to-know basis. That's very challenging to do because you have to determine what information is challenging to share, who are the appropriate users, and then who's in charge of implementing something that that would do such a thing. It's not impossible, but it's very challenging. And in the least, you could have a conversation about it in terms of, is there something we could do here? Or is this too far out of the realm of possibility that we could do for something like this? So lastly, I'll say, I recognize that this field is in my experience, advancing more rapidly than other things we've seen. 10 years ago, we were talking about CRISPR and how we would mitigate risk stemming from the kinds of engineering that CRISPR could do. But this is even faster than the advances in information technology, and information being out there in the world is advancing really, really rapidly. So in some ways, from a policy perspective, you may have to think of, we have to do something now in the face of this very rapid development, and what kinds of things could those be that don't necessarily generate harm to innovation. And if you have to take a pause on things, we have done that in the past, and maybe there are reasons to take a pause. So I will finish my comments saying, going back to the success of doing reviews of publication prior and how we've adopted that as a good practice, I would consider that a norm, a developing norm that came out of the experience we had then. And I'd encourage you to all think about what are norms in this information space and how could they be developed. And it's a good time for me to turn it over to Ken, because I think he could probably say a lot more about than I could. So thank you very much. I once again, thank you for allowing me to make comments to your meeting, and I really look forward to the outcomes.
Thank you, Diane. And you did a great summary and left us with 3 key questions. We're going to have more time to circle back on those questions shortly. I want to introduce our next speaker, who is Ken Oye. He's a professor of political science and data systems society at MIT. He's also the director of the program of emerging technologies. Ken, the floor is yours.
Thank you. Sound is working. Okay. I want to actually pick up on a number of the themes that Diane raised. I was asked to be speaking on, let's call them exemplary cases and cautionary tales on engaging with benefits and risks of emerging technologies in the past. Let's kick off by differentiating pretty clearly between the narrow and broad mandates. The narrow mandate would be to focusing on in silico and information and mechanisms for controlling diffusion of information alone, particularly with reference to AI-enabled applications, to preserve benefits and mitigate risk. In order to do that, I would suggest that we also take the mandate a little bit more broadly and be looking at a wider array of examples in bio that might provide, let's call them pointers towards ways of handling the specific and more narrow tasks that this committee is directed at. So I also don't want to be talking about H5N1 or some of the other examples that we have discussed. I'm going to be personal. And I'm going to actually not theorize, very unusual for an academic, but I'm going to tell stories. And the stories are going to be stories on management of benefits and risks, assessment of benefits and risks that I think do have broader implications. So let's talk about information on designs. There's this thing called trade secrets, and there's this thing called the patent system, which are designed to, let's call them, limit to some degree access to critical information, largely for self-interested purposes, but to create incentives for innovation. Most of us are also familiar with something called patent secrecy orders. And I know about this because my cousin, my wife's cousin, told me all about a great idea that he had, that he was planning to be using to finance his children's college education. Instead, he handed me a letter, and the letter said, "You are covered by a patent secrecy order. If you describe or disclose any of the information on this design, you are subject to prison terms, big fines, and the like." It didn't specify the appeals process, but it did indicate that talking to anyone about the problem could also land you in jail. Now, you understand the need to be limiting access to designs. In this instance, it could have been used for triggering nuclear weapons, driving the explosion, precise timing. On the other hand, there has to be a better way of preserving benefits while also addressing security risks. But I'm noting that the patent case is sort of a special case. Let's move beyond that one. if we're talking about information on what is possible, how to do it, but even information on what is possible can be critical in security terms. And publication. I'm going to tell stories again, and the stories are about two publications and experiences with two great sets of editors in managing diffusion risks. One of them was on gene drives. And the story here is that shortly after the H5N1 fight, a number of colleagues came up with the idea for CRISPR-enabled gene drives. They actually said, you know, there might be broader security and safety and environmental implications associated with this. Fair enough. Would you be interested in working on the policy implications with us? And the answer was yes. Now, the story here is that when we went to Science, a great editor, and I don't think she'd even mind being mentioned by name, Barbara Jasny, we had Barbara as our editor, and she was very worried about the broader security and safety implications of dissemination of information because it was right on the heels of H5N1 gain of function. So here's the question: what did she do and how did it work? What she did was we talked a lot about the risks, but she was also gossiping with all kinds of people to try to get a better sense of what the dangers might be, because there wasn't a specified handbook to say, here are the criteria for what's dangerous or not. Are there benefits? Yes, there was no question that maybe addressing malaria and other things could be beneficial. At one point, though, this was the most interesting part of her vetting. Barbara quietly got on the phone and said, have you talked to the NSA-BB? And I said, Barbara, the NSA-BB is not meeting now. We would have. And we talked to members of the NSA-BB, but they're not meeting to pass judgment. So you can't get off the hook that way. And then she thought for a second and said, have you talked to Ed Yu? Ed Yu, as many of you know, is the FBI supervisory special agent who was running the show in that area. And I said, yes, we have. Barbara doesn't trust. She said immediately, what's his personal cell phone number? And I gave it to her. I don't know if she called Ed or not, but the idea here of seeking broad input from a lot of people on what might constitute a risk was entirely appropriate. We ended up taking out some information that wasn't necessary for people to understand what was going on, but might have been useful to people who were just going to be doing a gene drive. The coda on this story is that we thought it was going to be a long time before anyone would do this sort of stuff. And less than 6 months after that publication, the team at UC San Diego did a gene drive. And less than a year afterwards, an iGEM undergraduate team at the University of Minnesota made significant progress toward doing a gene drive. The biosafety officer at Minnesota did not know that they were doing so. We did not have policies on it. And again, when you're talking control of information, assessment of risk, it's a weird case that has a lot in it. Fortunately, nothing bad happened, which is something we'll get back to. Another publication-related issue was at Nature. And in fact, it was Veronique Cremier. So Veronique, you don't normally get calls from editors of journals, but she was worried because we were going to be publishing a piece on the regulation of risks associated with opiate synthesis in yeast, you know, glucose to morphine and heroin. And again, wonderful engagement with editors, noting that personal engagement is critical. It isn't one size fits all. And the information that we provided was in fact calibrated to not be providing a cookbook for brewing bad. The, again, point of the story is that attentive and responsible editors engaging with authors and jointly trying to figure out what makes sense is not a bad way of doing it, assuming that the editors and the authors are trustworthy. And I mean that seriously in the sense that people have institutional and personal interests that must be taken into account when you're designing the systems. Moving beyond those to a point that Diane made, Okay, Diane made the remark that if any information gets out in any public space right now, AI will vacuum it up and make it available to others. And it's a point that is well taken. But there's also the possibility that instead of broadcast, our model could be narrowcast. That AI might ironically have a potential benefit in terms of addressing the problems that we face. And the benefit might be that you might be able to get the information to those that need it. You know, the old need for know that everyone in classification world understands. The idea that AI might be able to discriminate, differentiate, allow you to narrowcast and target individuals that need the information, be they biosafety officers or specified scientists, and restrict others, at least temporarily, could be a partial benefit of AI that might partially offset the vacuuming effect that Diane mentioned. So the final example that I want to give is one that involves directly a person sitting in this room. And it is a whole series of efforts to be assessing and evaluating benefits and risks of advanced biotechnology. The work was under the auspices of NSF, SINBRG, another NSF grant, and EPA. And it was a cooperative enterprise between the Woodrow Wilson Center, Dave Rajewski, and especially Todd Kukin, and MIT and some others. And what I want to do is take the remainder of this time to talk about a real difficult problem. Roger yesterday said, we don't see benefit risk assessments that are done in line with what's required by statute. Well, and I'm not saying that this did it, but it might offer some pointers to do this sort of work better. First, kudo. Jenya Dana and Anna Kapuscinski did a paper a long time ago on how to do risk assessment. And their main point was that you need to have a diverse group of people sitting in the room and working on it. You can't just do it with usual suspects. Their application was South Africa and GM crops. But we tried to take that principle and build it into what we were doing, Todd and others, on weird biotech, weird synthetic biology. So there were a couple of things that emerged. If design rule 1 was mix up the people in the room, yes, you have the biological engineers, yes, you have companies, you have the regulators. So we had Mark Siegel from EPA and Gwen, and we had the people from Fish and Wildlife and from the defense. But we also had people from business and people from NGOs, the pesky NGOs that were critics of synthetic biology, Friends of the Earth. But the next rule was to go with Chatham House rule. And we went with Chatham House rule because we didn't want people posturing. We wanted people to be focusing on what was in the room and not playing to the external audiences. And we also did a whole series of workshops so people would get to know each other well and maybe begin to trust each other. It worked in terms of the recognition of significant sources of uncertainty that were associated with evaluating benefit and risk. The environmental biologists were handing off to the engineers who were handing off to the NGO people, and for a while you couldn't tell who was who. What resulted were the usual big fat reports that no one reads, the usual shorter articles that you hope people read that you publish. But the most significant output, and Teresa, maybe you could speak to this one, we had a request for a one-page memorandum on research priorities on areas of uncertainty that NSF should address. That one-page memorandum, I want to tell you, it took longer to write than the articles, compressing it to one page. But we wrote it for Parag. And the idea here, and I mentioned this, because this kind of follow-up doesn't typically happen, but the idea of feeding back and interacting in order to direct resources towards addressing knowledge gaps preparatory to the next round is rare. And on that mildly optimistic note, I'll end and put Teresa Good on the spot, who's sitting there now running the division that followed from that memo.
Thank you so much, Ken, both for your storylines and also the key points that you touched on. We actually are now going into our Q&A session, and we have a few questions that we're going to start off with, and then we'll get back to Teresa and others who want to comment. One of the things that were touched on both by Dan and yourself, Ken, is that there's this need to either have a risk reward portfolio or understanding, a rubric that has many stakeholders that inform that rubric. So I wanted to ask a related question to what Diane asked in her first point, where she asked, what are the policies now? And put it in a context of some of the things that you brought up, Ken, is what is your historical perspective of one or two key policies that have been implemented that have engaged all stakeholders, including the scientist or engineer in the field, in designing safeguards and model evaluations? Several participants yesterday brought up the fact that AI and model developers are among the most aware of the details, and you mentioned needing the breadth of people involved. What are your thoughts on precedents for asking developers all the way up to the CEOs for the needs for safeguards, and then self-regulating those safeguards? Is that already happening? Dan, if you could start, and then we'll go back to Ken.
Yeah, wow. There are so many there are so many policies I could think of in their sort of development and implementation, but I'll take one that's easy for me to talk about, and that's related to this, and it was talked about, I think, a little bit yesterday, which is the DNA synthesis screening. I was actually at OSTP at the White House at the time and helped write the first one with my colleague Ben Petro. We created a working group that was out of the White House in response to someone did a red team on a company and said, I'd like to order a smallpox DNA. And the order was poised to be sent out. And people realized, this is probably a bad thing. And at that time, there were only 4 companies in the United States that made synthetic DNA. And those companies were concerned, and rightly so. And it was a very small conversation at that time. You figure there's 4 companies, there's been this one red teaming journal article that came out, but we need to start thinking about this because this is a real, this is a blind spot in our biosecurity toolbox. So now at this time, I would say the iteration of policy that has followed since then, we actually now have we have hundreds and hundreds and hundreds of all over the world, companies that are making DNA in ever more larger pieces and capabilities. And there's an organization, an international organization devoted to having screening for both sequences and customers, and how important that is. And we've had many dialogues among the federal government. We've talked about this policy even with state and local stakeholders in places where these companies exist and make DNAs. And those stakeholders are part of our preparedness and response regime, for example. So to me, that's an example of a success story. It started with a very small, oh my gosh, here's something we hadn't considered before in a small community. And as biotechnology grew and matured, so did the DNA screening guidance. So if there's a way that what's happening with AI and information technology could mimic that trajectory, I don't know. But certainly going from 4 companies to what we have now in the world is something that's happening with AI. So I'll pass it to Ken for his thoughts.
Okay, a couple examples. First, following directly on Diane's example of synthesis screening. A couple of things have been going on in the past couple of years that I think are worth noting, even beyond the official governmental activity. First, red teaming. You mentioned red teaming, but figuring out what works and doesn't work, where the holes are, is critical. And I think it was OpenPhil that funded a red teaming evaluation or assessment that showed that the holes were much larger than I think people would feel comfortable with. But following on that, it wasn't just saying, wring your hands and get upset. There also has been a really interesting activity that I think that Group 2 talked about a little bit yesterday, but I think it's worth raising here. And it's the creation of a multinational China, Europe, US consortium to be screening for novel stuff, not just the usual list. To be doing so with attention to information hazards that might be generated if you reveal information on the sequences of concern, with encryption and targeting of the information, breaking up the sequences so that no one's going to be sitting on top of the whole pile of information. But it's a really creative response funded by a foundation. It's not governmental, but with governmental agencies informed on what's going on. Because if you're talking about US, China, Europe, the concerns that are raised could be obvious and everyone needs to know and not believe there's something nefarious. The other example is explicitly governmental. So I'm not going to give the story of Asilomar again. We've all heard that. But the Recombinant DNA Advisory Committee out of NIH is nominally not concerned with security, but it kind of is. And the model there involved review of lots and lots of activity. Those reviews generated information on what was going on in the field, and that information in turn fed back in and was information that could be used to determine what to worry about. That was replaced. So the RAC was replaced by NextRAC, the Novel and Exceptionals Research Advisory Committee, which Gigi and I are both members of. We're sort of members, but it's one of those many committees that are not meeting right now. Very different setup, long-range scanning, trying to figure out what to worry about without the onerous project review function that was part of the Recombinant DNA Advisory Committee. And there's good and bad in the redesign. The good is the freedom to be thinking big thoughts and looking at emerging novel technologies. The bad news is that it's kind of cut off from the information provided by looking at what people are actually doing. And I mentioned that in part because of that iGEM story that I told you about. I was co-chairing, I should say, the iGEM Biosecurity and Biosafety Committee when that happened. And I got to tell you that we keep learning, unfortunately, about what people can do by sitting there looking at projects. The gray hair actually came about from doing that too much, but knowing is better than not knowing. And the RAC did know about projects much more than the next RAC does.
Thank you, Ken. We actually have a number of audience questions, and I'd like to put the top ones up front. The first question we have is from Jake Beal. He says he likes the point about responsible editors, but the examples are top journals. What do you do about editors who are barely paying attention, as is often the case at lower ranked journals? Diane or Ken, do you want to take a stab at this? What do you want to do about editors? I guess that's what suggestions do you have for editors who are not paying attention or barely paying attention is often the case, which might be often the case at lower ranked journals.
I might defer that one to Ken first.
I recommend that editors organize themselves and do some self-education. The editors that I know, and it may be a select subsection, but others as well, are surprisingly attentive to these concerns. So at the same time, the problem may be that, okay, look, you don't necessarily know what to be worried about. So when we were doing that gene drive paper, Barbara did not know what a gene drive was, and other editors in science didn't know. And in fact, when UC San Diego did their paper realizing a gene drive, they didn't realize what they'd created. And the initial editor at Science didn't know that there were potentially interesting broader implications associated with it. Barbara happened to stumble across the UC San Diego manuscript and said, whoa, there are issues here that you're not being attentive to. But it wasn't that people were malevolent or had bad attitudes. It was knowledge just wasn't there. And the problem is that if you restrict knowledge, you're also restricting access to the information that the editors need to be responsible, or biosafety officers need to be responsible. So it's a bit of a conundrum.
I do just want to push back here a little bit. I've seen journals where the key problem is, can you even get the editor to put in enough time to select reviewers within 2 months? I have a very hard time believing that those sorts of editors are going to consider these questions.
You're right. Science and nature are not typical, and they have the resources and the skills to do more. The fact that there are potential issues like this, even in journals with those resources, that quality, and the number of, well, they're not short of manuscript submissions, is not typical. Fair point.
We have two other follow-up questions that relate to where does the responsibility lie? One is from Jeremy Zucker, and it's about, he describes that we're really talking about information security. I wonder if policies, practices, and frameworks in cybersecurity communities might be helpful for understanding in silico modeling, specifically a perp and DIRC in silico modeling. Would controlled unclassified information reviews be helpful? Diane, do you want to take this before Ken, we'll go to you.
Yeah, I think that's a good question. I think there's a lot to be learned from the cybersecurity realm, and didn't mention in my comments, and because Ken brought it up, I want to reiterate it here, is the idea of red teaming, and the red teaming that was done by NTI and some of the DNA screening. There's red teaming beginning to go on with some of these AI large learning models, and they are, they're challenging, but I think they need to be done. And I think that if we can build something that, build it to a norm where prior to release of any of these LLMs, in their various iterations, that they've been red teamed first for particular things, and the challenge is, who designs those things and for what purpose, because there are many different kinds of risks represented there outside of even the bio realm. But I think this idea of red team is really important. If that could be something that we do more regularly, like we do in the cybersecurity realm with these AAIs, that'd be great. And even with some of the models, if they're intended to be computational models that would be shared, more broadly, I think red teaming is important. The other part of that question, I think, was about CUI, and certainly some of these red team efforts, because they're expensive to have human beings sit and red team the models, and the models aren't publicly accessible yet. Most of that is going on under NDA agreements or other kinds of things where they have not been publicized yet. Hopefully we will get to that stage, and hopefully we will get to building a set of proxy tools that could be used more regularly, that could stem out of these red teams. So in other words, we now have viral software, compliance software, all these other things that we use in the cyber security realm. What is the equivalent of that in the AI realm? So if you're just a small guy putting out a AI, you can apply this proxy tool to say, is there risk represented in a certain category from what I want to release to the public? So it'd be great if we could get to that class. The last thing I will say is, one thing that's good about the cybersecurity issue is that there have been many international agreements brokered between countries willing to do cybersecurity agreements, particularly in the financial world and around banking and finances. And so is there a way we can leverage some of those kinds of goodwill agreements for this type of thing? That would be interesting as well. Those are my thoughts.
Thank you, Diane. I actually want to merge the question with another question that was in the chat, and an additional one that came up from what you mentioned, Ken. And that is, Diane mentioned red teaming and international collaborations. And there's another question on the responsibility of the authors themselves rather than the publishers. Where does the balance lie for Moritz? And I have a follow-up. You mentioned a large-scale collaboration where already the DNA chains are being broken up and encrypted in a way that they're stored securely, and there's a collaboration between many competing, potentially, nations. Along those lines, what are your perspectives on engaging other countries, even competitors, in designing standards or rubrics on data sets that can be used for benchmarking or as an example, like in medical field, doctors have to take CME exams every year. Should our AI equivalent agents be taking CME exams every year? And that's a standard, or are there specific functions for variant calls that we should look for in our AI models that are trained on genetic data?
So really picking up on exactly the last part of your question, if we look to the data sets that are critical for the large language models to feed on, to chew on, the integrated data sets with genomic information and clinical information put together, that is the seed corn that AI feeds on. If we look internationally at standards for the regulation of that data, who owns it, what are the privacy considerations, the variation in those standards is enormous. And every country that I've worked with has been worrying, because the trade-off against effective utilization of that information and protection of privacy, they run against each other, with security adding a whole nother layer to it. I was a consultant to the government of Korea, South Korea, just to be clear. And their concern, well, what they wanted to do was to catch up with the US and Europe and Japan. They were producing generics, but they wanted to be pharmaceutical innovators. And they thought a pathway to doing that was by, in fact, getting on top of data in the way that China has done. And their regulations made it effectively impossible to use that data in an integrated way. They had it, but they couldn't use it. The issues that you raise make those problems even more complex, and the international variation in security standards on top of others is huge. A final note on that follows from Diane's earlier remarks on cybersecurity. You mentioned, Diane, how banking, for example, took it very seriously, the threats to getting hacked. And one thing that we might take away from the cyber world is the fact that you had different standards for cybersecurity that were generated by different sub-communities. So the bankers were quite concerned about cybersecurity after some hacks. The utilities were quite worried about cybersecurity when there were too many science fiction stories and movies about disaster. The national security community is obviously much more worried, social media less so. But this may be an instance or a case where differential standards are appropriate depending on the use community. And I'm just raising that as something that we ought to chew on.
Thank you so much. I think we're closing right now. And thank you very much, Ken and Diane, and audience who put in their questions in Slido. We're going to break now. So
Thank you, Amina. Thanks,
See you,
Ken.
Diane.
thank you, Diane. Thank you, Ken.
Wish you were here, Diane.
I do too. I'm missing all the fun.
I'm going to send you a copy.
I'm with you in spirit and I'm listening in.
Which will be moderated by our planning committee member, Richard Sever here. Richard?
Hi, I'm Richard Sever. I'm the Assistant Director of Cold Spring Harbor Laboratory Press and co-founder of the preprint servers BioArchive and MedArchive. The next session is on in silico modeling and AI safety and security lessons from other domains. And our goal here is going to be to explore how experiences in other domains where there are serious risks to dissemination might inform policies, guidelines, and best practices we can consider in debating how and whether to disseminate in silico research with potential can you not hear me? With potential biosecurity risks. We have three great speakers to discuss this, talking from areas of pharmacology to cybersecurity. We're going to start with Stein Sigurdsson, who is a professor of astrophysics at Penn State University and the scientific director of Archive. And he's going to share some stories about past in silico experiences. So Stein, if you'd like to unmute, turn on your camera and share your screen.
Yeah, I had to quit Zoom to be able to share screen. So, hi everybody, I'm Stein, I'm a physicist. And I'm here in my capacity as Archive Science Director, initially to tell some stories. So to set context, while I get screen sharing back on again, a long time ago, I was working on some computational tasks, trying to get all the pop-up buttons to let me do what I need to do. I was working on some testing of new computational systems, which involved running state-of-the-art code back then, involving nuclear reaction networks and radiation transport in very hot plasma. Fun stuff. So setting it up, and we we're going to do some tests. And a very senior astronomer came to me and said, "You know, you have to apply the astronomer's correction." And I was like, "What?" And he said, "The astronomer's correction. Just do it." And the astronomer's correction is that apparently radiation transport back then worked differently in space than it did on the ground, by a significant amount for certain temperatures, densities, and compositions. So I did this, and it worked. The equivalence principle had not been broken. Some years later, the national lab that at enormous expense had generated the data we were using computational models, issued a quiet correction, conceding that in fact the astronomer's correction applied on the ground. And we all were very quiet and carried on as normal. So this was a published, well-distributed thing. It was an output of a computational effort that was at the time a national endeavor. It was not something you did in your basement. I could reproduce that table right now on my phone from scratch. It was a deliberate error. It was very quickly obvious to people who knew what they were doing that it was a deliberate error. And it is somewhat analogous to an alleged error in the well-known anarchist cookbook. There are some recipes out there you should not follow unless you know exactly what you're doing to begin with. The core issue is this was a computational modeling effort. The data that was being used generated computationally from ab initio modeling. The catch is that it contradicted observations. There was a separate domain where observations did not fit this data, so we knew there was a problem. And the reason this worked is because the computational modeling was hard. The people who might be interested in knowing that the error was there did not have the capability to reproduce it and understand that the error was there. And the people who knew unofficially pretty much agreed to keep quiet about it on a need-to-know basis. This was very informal. And now the reason it was published and the error correction was made is because it went from being a hard problem to being a trivial problem because computational capabilities improved. Something that was absolutely classified, you must not know about this, smoothly transitioned into a bored high schooler could do this with a bit of Python code on their phone, if they could figure out how to hack their phone to run Python. Okay, so for context, for those of you who don't know about Archive, it is the original gangster preprint server, and it mostly works in physics, mathematics, and computer science. We also do other little things, including quantitative biology. For the context of scope, we do approximately 20,000 papers a month. That's about 1,000 per working day, of which about 2% are in quantitative bio, or roughly 5,000 per year. So we have a high impact, for example, in epidemiology, but we also have a surprisingly interesting impact in computational modeling, since we do a very large fraction of computer science, and in particular, essentially all the AI stuff comes through archive. That is where you go to find out what just happened in AI. Type of content types we have, there's very little biological experimental stuff on archive and almost no clinical stuff. Crudely speaking, we avoid normative stuff. We are focused on quantitative, mathematical-based stuff and shy away from normative fields of science. So we're looking at ab initio models, a lot of data analysis, and a lot of data modeling. We also, interestingly, have substantial presence in computational analysis of social networks. There are whole sections on archive that deal with dynamics of the dark web, spread of misinformation, and tests and experiments in that space. We do not review papers. That is not part of archive's job. The papers goes out there fast, and the intent is that it is open, it's free, and it is there to speed up research, to accelerate the circulation of information and get synergistic effects. We also do take some responsibility. We have cautionary tales. We also found that cautionary tales very quickly become how-to manuals. You tell people about something, say, this is bad, and people are like, oh, cool, I'm going to try that. We touch on most of the topics that have been covered in this meeting, which I guess is part of the reason I'm here. Also, interestingly enough, we talk to people, and a few years ago, I got a call from my national lab, and it said, you're about to receive some papers. I just want to let you know in advance that this is the list of papers, and they have been declassified. The papers were almost, but not quite, all the papers you need to do the engineering and construction of a Hiroshima-level fission bomb. The photo of Niels Bohr skiing in New Mexico was classified for 10 years. Nobody was supposed to know he was even there, or even alive, technically. This is from a paper that came out with a batch of several dozen papers. 1 minute, whoa. Okay, I'll talk really fast. Well, if you want to know what explosive they used, the formula is there. All right, so what do? One thing to know is when you go out on something like archive, within 100 milliseconds, the content is copied, archived somewhere else by third parties, surprisingly many of which are in Northeast China, and the rest are in Moscow. It becomes instantly discoverable. In fact, we are hammered by AIs every second of the day, mining our data and cross-correlating it. We do actions. We can do corrections. We can do takedowns. We can expedite retractions, and we can do removal, some of which are authored or initiated by ourselves, some of which come from our readers who highlight to us that there's a problem, some of which involve calls with lawyers, and an interestingly small number of which involve conversations with people in tall buildings not very far from here who make suggestions. These are not hypotheticals, these are explicit, they're explicit examples, which I might mention in Chatham Rule meeting, but not on the internet. Lessons learned. 1, the content is forever. As soon as it touches the internet and it's placed like on a preprint server, it's copied, it's distributed, and it's discoverable. There's a continuous battle in there between people siphoning the content and people curating content. There is a Streisand effect. And this is very important for thinking about how you want to deal with stuff that is released inadvertently. One of the patterns people look for is what disappeared. And once you see something has disappeared, it's more interesting. And you can find it if you know what to look for. This is an important point. Sometimes, therefore, content you think should be deleted is not deleted by request. don't draw attention to this by deleting it. It's safer to just leave it out there and hope people don't realize what's in there. The other thing is that there's a massive and very rapidly growing use of AI tools, and they work both ways. We use them on our side to scan things for concerning stuff. We're behind the curve because the people who are finding things with AI tools have much more resources and money than we do. We are using volunteers and doing things in our spare time to do this. The people who are doing this are doing it as an industry with large teams. And that's where I was going to stop.
Okay, thanks very much, Stein. We'll move on. We're going to do Q&A at the end. We're going to move on now to our next speaker, Sean Atkins, who's founder and CEO of Collaborations Pharmaceuticals, and he's going to discuss some lessons from misuse of generative AI in drug discovery.
Hopefully you can hear me okay.
Yeah, we can hear you.
Good afternoon, everyone. I'd like to thank the organizers for inviting me. What follows is a very brief overview of a very cautionary tale. So about 2021, I was invited by the organizers of a conference in Switzerland called the SPIES Convergence Conference to possibly present something in which I misused AI. I should say as background that I've been using computational approaches for drug discovery at that point for close to 25 plus years, and never once thought that I would misuse the technologies that I had. And this was interesting. I'd never heard of the conference, and I obviously forgot about it until a couple of weeks before the conference. I was reminded I had to present, and quickly scrambled to come up with an idea, came up with three, and one of them was to use a recently developed technology that we've been building, generative design of small molecules. I thought it might be interesting to do VX and use some of the models that we had available to us, primarily because we had the models. We had an acetylcholinesterase inhibition model that we've been using, working on an Alzheimer's project. And we also had acute oral toxicity in rat model that we've been working on. All of the data was open, available from government websites or Kemble or wherever. So we did this overnight and came up with an example. And we presented that at the conference a couple of weeks later and got a little bit of attention. And that led us obviously to think about, well, what do we do next? And so we came up with a bright idea of publishing it. And obviously there are experts at that conference, and a couple of them, Philippa Lentzos, that many of you may know, and Cedric Invernizzi from the SPIES organization in Switzerland, thought it would be good to do this. So we quickly drafted a manuscript, a very short manuscript, and got approval from the folks at SPIES to publish it. We obviously thought the best place to publish it would be Science. They disagreed. It was rejected immediately. They didn't think it was of broad enough interest. So apologies to those from Science that are here if I've oversimplified the review process. We were a little bit upset because we thought it had some interest. And obviously then we submitted to Nature Machine Intelligence that we thought was a youngish, up-and-coming journal, probably relevant. They took 5 months to review it. We went backwards and forwards, and ultimately it came out by mistake. They published it, and the first I knew about it was a blog, ironically, on the Science imprint, I guess, in the pipeline, AAS owned, which had highlighted this manuscript, and we were very surprised that it had actually come out. And I guess as recompense, the journal decided to make it open for a month. Obviously, it's a closed access journal, and that obviously drove a lot of virality. So if you really wanted to draw attention to a paper on a topic, that would be one way to do it. Publish accidentally. Journal decides that they're just going to make it open access so anyone in the world can look at it. And yeah, a fun time was had by all. So what's really missing from the story? Well, we had review. SPIES reviewed it. These are experts in the field of dual use. They approved it before we submitted it. I was obviously a novice, had no idea what I was doing, other than doing the science, which I thought was kind of interesting. The editors at the journal thought it would be wise to censor it a little bit, and obviously the reviewers did. So it was censored even beyond what we censored. Publication took a while, so obviously they were going through legal, although they never disclosed that to us. And as I said, the publication was ultimately accidental. They made a mistake in putting it out. And then obviously it kind of hit the fan a little bit and people got a bit excited about it. And within a couple of weeks, we were giving presentations to everyone, including the White House. Some of these were just a little bit too much, really. And then my colleagues also decided they would highlight it at other popular places. The best thing I think that happened was I got to go to Brazil in 2023 on a US government State Department sponsored initiative to raise awareness of AI misuse in Brazil, which was great. The most scary thing was the FBI telephone call. I don't know if that was real or not, but it sounded pretty real. And yeah, overall, it generated a lot of interest. People wanted the software so that they could design chemical weapons, and obviously we said no. Got a lot of press. Some of the press was amazing, especially I was quite happy with The Economist. They managed to summarize a 2-page paper in a page, which was great. Drove even more interest in the paper. And the press just kept going on for about a year or two. We did a few podcasts that raised a little bit more visibility. If you really didn't want to raise visibility for something, we did a really good job of doing it. Radio Lab, podcasts, Future of Life, you name it. Everyone wanted to hear about it. And yeah, within a couple of weeks of the article coming out, I was approached by producers from Netflix. They wanted to do a documentary. What followed was a year of filming. Essentially 6 days of my life was spent filming for Netflix, of which 15 minutes made it into a documentary called Unknown Killer Robots. We did nothing on robots. We did nothing about killing robots, but we managed to get into it. It's worth a watch. I think that probably the most interesting thing that came out is people raised even more visibility for the article, publishing it in policy documents. So if you really wanted to not draw attention to something, you probably wouldn't want to cite it, right? I've not read all of these documents, and this is just a handful of them that have cited it over the last year or so, including the most recent from the National Academies. I'm obviously very honored to be in these. We came up with recommendations very quickly, published those. We actually published a few papers after the first paper that drew the attention. These were very naive attempts at trying to come up with recommendations of how to put the genie back into the bottle. And obviously none of them were original. Other than perhaps maybe that we need to do ethics training. And so my take-home points really following on, I think, from a lot of discussion here. I'd never had any experience of dual use before at all, I'm afraid. Never had any training about it. I published a lot of papers. I'd never published anything like this before. I had no oversight. I own my own company, so I am the oversight. Didn't do any benefit risk assessment other than I thought maybe going to SPIES in Switzerland might be fun. It turned out to be a Zoom conference. So that was lost on me. Didn't have any risk mitigation plan. Got myself into a bit of hot water, spoke to a lot of government agencies. And the outcome of it maybe is I made $30,000 with a project with a consumer product company that wanted to design new polymers, totally unrelated. So I think the upside is small win. Downside is a lot of stress, a lot of sleepless nights. My concerns now today are very different to what they were a few years ago when this came out. My concerns are if we restrict AI, these types of generative AI that we were using, could this be used as a broader attack on science? But then, the flip side of that is, well, the current administration is doing a pretty good job of attacking science without AI. So what could be more dangerous? That's a tough choice. Ultimately, I think I come back to we just need more ethics training. Publishing is a mess, I'll be quite honest. I mean, I think if I had my time again, probably wouldn't have published it. And that's it. Thank you.
Well, thanks very much, Sean. That was a fascinating story. We're now going to move on to our third speaker, Nandi Leslie, who's Principal Technical Fellow at RTX, and she's going to tell us about some lessons from the cyberspace. We can't hear you right now, Nandi.
Nandi, we're unable to hear you. Could you leave your audio and come back?
How about now? Can you hear me?
Yeah, that's great.
Thank you very much.
Okay. Awesome. Let's see, I'll share a few slides to facilitate the discussion. Can you see my slides?
Yes.
Awesome. Yeah, so basically I was asked to discuss some of my experiences at the intersection of cybersecurity and AI and machine learning. And yes, I'll do just that. Just to kind of give you an idea about myself, as was mentioned, I'm a principal technical fellow at RTX and at Raytheon, a business unit of RTX. Raytheon is an aerospace and defense corporation, quite large, over 100,000 engineers, which does quite a bit of business globally in A&D. And two other business units are Pratt & Whitney and Collins Aerospace. I've served on a number of National Academies boards and other boards as well, and looking at the intersection of AI and machine learning. That's really my passion, is as an applied mathematician and doing research that is at the intersection of modeling and simulation in general, but also specifically machine learning, and looking at how it can be applied to theoretical biology, and more recently, cybersecurity. And, some of the challenges historically in cybersecurity have been at the, looking at the question of signatures versus anomalies. For the past, let's say, 40 years in cybersecurity, since about the 80s, when the notion under a different name than cybersecurity of intrusion detection and network intrusion detection was kind of, initially, entered into the research discussion. There was this notion of we have really good signatures, but having even the best signatures for cyber attackers is inadequate. And how do we use computational methods, such as those that tend to be used in anomaly detection universally, to apply to network intrusion detection and other cybersecurity and resilience problems? And, that work has been burgeoning for over the past 40 years. And even still to this day in cybersecurity, signatures tend to be used, largely over anomaly detection, even though zero-day attacks are attacks that don't have known signatures. So the signatures are unknown, and anomaly detection would really be the only method to find those. And so, but anomaly detection presents its own issues, right? And those generally are that there are quite a bit of false positives, and other errors that can emerge with anomaly detection that don't exist with signature-based detection. And so though many approaches, modeling and simulation approaches, in addition to machine learning, that exist for anomaly detection that try and reduce those errors. And one huge area of study is how does one organize intrusion detection to improve prediction with machine learning approaches, but not just machine learning, other computational approaches as well. And so those are some of the challenges in cybersecurity, and they also present opportunities for the use of AI, machine learning, and other computational approaches for cybersecurity. And these approaches and these, in fact, even the challenges present opportunities for consideration in silico biological studies. And some of those challenges are presented in the colored areas here. So for example, there are data quality and availability challenges. And there are, opportunities to use AI to address some of those challenges, say in data quality and cleaning the data, for example, and there's missing data, and filling those gaps and with missing data, of the missing data with AI approaches. But of course, another challenge that AI presents is it requires volumes of data, especially generative approaches, in order to make headway. And additional challenges is that there are implementation complexities, and one needs to have a deep understanding of machine learning and likewise of cyber in order to implement these algorithms, to know which algorithms to implement and that are kind of the best fit for the data under consideration. There are privacy issues, there are security issues, there are data privacy requirements and laws that need to be considered. And these are some things that are, definitely can be considered in silico studies as well, because they're kind of tangential really to the issues that maybe present themselves, say, for example, with HIPAA laws. There are adversarial attacks on the AI algorithms themselves. So there are, attacks on the algorithms, say, for example, with deep learning, on the weights. There are attacks, poisoning attacks to the training data. There are attacks to the implementation of the model post training at the decision-making phase of the algorithms. And so adversarial learning, adversarial AI presents challenges and opportunities. It presents challenges in part because of, well, in the cyber realm, because, for example, network intrusion algorithms can be attacked if they're AI-based. And instead of detecting a unauthorized access to a system, they can in fact cause a false negative where the attack is not detected. They present opportunities, for example, well, one is offensive cyber, but two is also to just ensure that there is robustness in the AI based algorithms for cybersecurity. And this is also something that can be leveraged for biological studies where modeling and simulation is also being used. And for example, the vulnerabilities that those algorithms face to bad actors. We talked about red teaming in this workshop. That's something that's often, or wargaming is another, tabletops. These types of events, occurrences are often used in cyber in cyberspace to understand where the vulnerabilities exist. They also are starting to take place in sort of the machine learning operations, ML ops, to see where vulnerabilities exist in that pipeline as well. And these processes can be leveraged for biological studies, computational biological studies as well. You know, unsupervised learning is probably one of the more challenging areas within machine learning. We get a lot of focus on natural language, you know, NLP. We get a lot of focus these days on LLMs, and you know, rightfully so. Unsupervised learning presents its own additional challenges because there are large volumes of unlabeled data that exist in multiple realms. And this is where unsupervised learning shines, where one can use these types of algorithms to analyze that those sets of unlabeled data. And unlabeled data exists in biological studies as well, just as many other domains, like cybersecurity. And one still wants to understand what's going on with that unlabeled data. And so clustering algorithms are just an example of a class of algorithms that can be used to predict the communities or clusters in a feature space, a multidimensional feature space. And observing that distance from the normal data, measuring the similarity between clusters, visualizing the patterns. All of these are some of the high-level techniques that one can use to examine the predictions from clustering. And these challenges, challenges that you know, we're trying as a community to understand within machine learning for unsupervised learning questions in particular can also be leveraged for biological studies.
Just to note, we're running a bit tight on time, so if you can start winding up now, that would be great.
Okay, yeah, exactly. No problem. This is the last slide. And so another opportunity for you know, machine learning and its application to DevSecOps and potentially further application to biological studies is this whole MLOps implementation pipeline that is used for DevSecOps. And one can consider these processes as well for computational studies in the biological sciences. So, you know, just in particular, how can one leverage automation and autonomy in order to improve the DevSecOps pipeline, and then, you know, ensure that that's applied to appropriately to computational biological studies. Any questions?
Okay, thanks very much. Yeah, we have time, I think, for one question, and I thought this would be interesting to get all three of your perspective on this. Stein, you talked about things where there might be a need to know basis, and this speaks to something that's come up quite a lot during this meeting, is the idea of controlled access. I'm interested what the three of you think about the real possibilities to work with information where some people have a need to know basis and get access on that. And do you think that's really feasible, Stein?
It's feasible because it's being done and has been done for decades. It is counter to the general drive towards open science and that you do better accelerating openly. It is sometimes arguably very necessary and mostly futile, except in terms of just delaying things a little bit, because everything's moving faster. We're not going to get decades, we're going to get months.
Sean, your thoughts?
Sorry, could you just repeat that? I missed a bit of it. Sorry, Richard.
It was the one of the things that Stein had brought up was the idea that you have a need to know basis, and some people get access to this, and we talk about controlled access and how you do this. There are obviously issues with equity, and as Stein pointed out, is it doable? How long is it going to last? I'm kind of interested what you think in the drug discovery space.
Well, normally I think we would just be making drugs and not chemical weapons, and I think that's the big disconnect, right? I mean, I think I would have to really be, going kind of left field to want to make chemical weapons, and I think that's sort of being in that vacuum of, ordinarily doing the same thing, just working on drugs and then moving into a different space. I think there's just that challenge, and I don't know about the need to know part of it, because I mean, even when we did it, yes, I felt that it was probably not a good thing, but yeah, I don't know how you put that back, because there were two of us that were involved in the project, and so ultimately everyone knew in the company what we had done, and then obviously when it was published, I mean, we'd kind of gone too far. So yeah, I don't know how you put it back into the box, right?
Yeah. Nandy, any thoughts on that?
Yeah, I think that there are certainly cases where need to know and classification levels should be applied, whether it's, in terms of Department of Defense, national security related issues where it makes sense to classify the data accordingly, and have need to know. However, I also think that one needs to do that judiciously, and ensure that one enters into the research and development community's discussions, widely speaking, and make algorithms, models, data open for peer review and evaluation by a greater community to find errors, make improvements rapidly. And so that there's a trade-off between classifying models, data, etc., analyses, and making it open access. And that trade-off needs to be balanced and well understood per problem. It's not there's not one blanket solution for that.
Yeah, I think that's a great point, and we have to wind it up here because we're going to go on to a break and come back. I think we'll come back to the point that you just made in the next session, which is going to be chaired by Sarah Carter. So thank you very much, the three of you, for all your insights into this problem.
All right, hello, everybody. We're going to get started here with session 8. I am Sarah Carter at Science Policy Consulting. I've worked closely on biosecurity issues for 15 plus years, including on the potential for misuse of life sciences tools and capabilities. In recent years, I've worked closely with NTI, the Nuclear Threat Initiative on these topics, and especially the intersection of AI with the life sciences. I am also a senior fellow at the Federation of American Scientists. The goal of this session, session 8 on policy options and norms for responsible dissemination, is to capture and discuss much of the discussion in the breakout sessions yesterday and to unpack some of those issues that were raised. And as you can see on the agenda, this session is not just a discussion panel, but it is an interactive, cross-sectoral, transdisciplinary, and solution-building panel. And so we're going to see how far we can get to set up the breakout session that's going to follow this session, where we're really going to put pen to paper and really try to come up with ideas or options or paths forward. So first, the way this is going to work is that panelists will provide 2 minutes of opening remarks, just 2 minutes each, with just their name, position, and some of the actions that they've taken or seen at their levels towards solving some of these specific issues. Then we're going to have committee representatives from each of the day 1 breakout rooms that will briefly present on one of 3 themes that we've sort of pulled out that we felt came up repeatedly in those breakouts. And then provide some thoughts from their own perspectives for about 3 to 5 minutes per breakout. And then for each of those 3 themes, the panel will have 10 or 15 minutes to debate and explore innovative, coordinated, integrated policy options and guidance for each of those topics. In parallel with that, one thing that we're going to do is that when the panel discussion brings up ideas in you, if you are so inspired, attendees can submit ideas through the online Slido platform. So we're not doing questions for this panel, but ideas and, priorities, solutions. And then we're going to collect up those Slido ideas to use them to help start the conversations in the breakout rooms in the session that immediately follows this one. So in addition to providing some solutions and ideas, everybody can upvote those different ideas that other people have. So we can really get to a good prioritized list of ideas to start the discussion and build on those sort of policy solutions. So we have panelists today. We are going to invite Teresa Good from NSF to give a little 2-minute blurb before we introduce the rest of the panelists. I know that Ken called her out earlier, and it is, as we talk through, one of the major themes in the breakout session yesterday was the stakeholders involved and how broad the stakeholders are for these discussions. And I know that Teresa does have a unique perspective on that. So I was going to give her 2 minutes to provide a little perspective on how these issues came to be discussed in the life sciences context. And then we'll get to the panelists on the, on the list on the agenda. So go ahead, Teresa.
All right, so I came to NSF the way that most people come to NSF. We're rotators from academia. I never thought about biosecurity, and I was put in charge of the kind of being the program manager for SynBERC, the Synthetic Biology Engineering Research Center that is this new technology in 2010. And I know nothing about it, and I never think about it. And so part of what happened at SynBERC is not only did that community really develop some ways of thinking creatively about biosecurity, biosafety in the context of synthetic biology, but they really exposed a whole generation of program officers at NSF, of the community across the interagency to really think about that. And so I would never have thought about those things if it had not been meeting Ken. But then what that did is that every time we have run a program in synthetic biology or related areas of biotechnology, whether it is the Ideas Lab that Charlie ran in synthetic cells or our designer cell solicitation, we have included social scientists, policy people within both the review and as part of the research teams. And it really does change or has informed the way we do things. And now, as we have launched research security efforts across the agency in quantum and other things, it also, the way that we have thought about biosecurity from those days also helps us think about how we think about research security in terms of quantum or AI or other things. And so it really is part of changing culture, and it changes culture within the agency and hopefully within the academic community. And this is not going to work if not all of the stakeholders understand this culture of biosafety, biosecurity.
Thanks so much, Teresa. That sets us up really well for, we are trying to move a field in a direction, and it's nice to know that it has moved before and can move in the future. So I think that's a good place to start in this discussion. I am going to introduce now our panelists, and I'm going to introduce them all in a row, and then we'll go to each one to give those very brief 2-minute remarks on their interest and perspective in this conversation. So our panelists today, all of them are online except for Richard. So our panelists today are Jim Brace, who is the Deputy Associate Director for Computing at Lawrence Livermore National Lab, Jennifer Gibson, who is Executive Director at Dryad, Mike Imperiali, who is a Professor Emeritus in the Department of Microbiology and Immunology at the University of Michigan, Girish Patange, who is a Technology Executive at the Chan Zuckerberg Initiative, and Richard Sever, one of our fellow committee members here, who is Assistant Director of Cold Spring Harbor Laboratory Press and co-founder of the preprint servers BioArchive and medRxiv. As a reminder, all of the speakers' bios can be found on the website, which is going to be put into the chat again here. So we are going to start with Jim Brace. So Jim, go ahead, unmute yourself and have 2 minutes just to introduce your perspective. Go ahead.
Okay, great. Can you hear me?
Yes, so we can.
Okay, great. Yeah, I'm Jim Brazzi. I lead the biodefense program at Lawrence Livermore National Lab. In that program, we basically bring together large-scale computing, AI models, and with experimental systems. And our job generally is to develop these, to develop capabilities for our government sponsors at DoD, HHS, DHS, and so on. In early warning capabilities, in accelerated countermeasures, and in biomaterials and manufacturing broadly. We have about 350 or 400 people working on this at Lawrence Livermore, so it's a small program at Livermore, but pretty active, and it's been growing a lot. Our biggest single program is called GUIDE. It's a work with the DoD on developing computational design of monoclonal antibodies. And we're doing that for a number of different warfighter support applications and so on. And we've demonstrated that we can do this successfully with experimental validation in the course of a few weeks, and have a pretty strong capability in that area now. This all involves setting up complex workflows with large scale generative and predictive AI models. Interacting with experimental systems for validation, for supplementing training sets, and so on. In all of this, safety and security is very important. So we have established processes we go through on that. We do safety reviews, security reviews, DIRC and PEP reviews in all of this. And we are working on extending that now into the computational elements of this. But I would say that, there's very little work that's just purely computational or purely experimental. Almost all of our programs integrate the two together. So part of that is on, pre-start reviews and so on, but a lot of it is on product release reviews and decisions. So we're making these decisions every day, from data to component models to larger design systems and so on. How much do we release? How do we give access to partners? There are partners from academia, from companies, from other agencies and so on involved in every one of these projects. And so there are decisions like this we're making all the time, and we definitely do not have the tools that we need or the policies that we need in place to make those decisions in, I think, systematic and consistent and defendable ways. So I'll stop there.
Great, thank you. Next, we'll go to Jennifer. Jennifer, you can unmute yourself. You have 2 minutes.
Thanks, Sarah. How's my sound?
Yep, we can hear you just fine.
Super. Thanks very much for including Dryad in this conversation. Dryad is a nonprofit organization working in the community interest to openly publish research data from across disciplines. Dryad was started in 2007 by researchers seeking to share data that didn't belong in a specific specialist repository because the file types were too variable. We are therefore classed as what's called a generalist repository and sit alongside Figshare, Zenodo, Dataverse, and a couple of others. What's different about Dryad and why it makes particular sense for us to be a part of the conversation today and yesterday is that we're the only generalist repository to curate data before it's published. And as an essential component of our curation service, we help researchers sharing data to understand what is acceptable to be released into the open and what is not. We do that with the support of a human team of curators whose role it is to check every submission and ensure that data files are present. They can be opened with readily available software. They include essential metadata and are fair. They've got a README file. They're well described for reuse. They don't include any sensitive information, importantly, and they may be released into the public domain. We're optimistic, thinking about the conversation last couple of days, we're optimistic that as a result of this process of labeling the data and opening the data, that the Dryad corpus is an important input for developing LLMs and using AI responsibly to support sound research. Going back momentarily to the topic of sensitive data, our curators are checking that data files don't include human identifiable information or the exact geolocation data for endangered species. For human subject information, they're checking that direct identifiers are removed and that there's only a limited number of indirect identifiers, that our author affiliations don't reveal the recruitment pool for the subject population, etc. And what they do is attempt to shield sensitive information or work with the author to remove it if so doing doesn't undermine the point of the data, or they may refuse to publish it. At the moment, Dryad only publishes data that may be released into the public domain under CC0 license waiver and will refer authors to another repository for controlled access. Our process was designed to make data as useful as possible to encourage reuse. Our platform is an essential component of the ecosystem that drives open science and the system in which all of the outcomes from research are made openly available as soon as they're available in order that we can leverage the digital networked environment to accelerate the pace of research. At the same time, in the data community, there's clear alignment that not all data is appropriate to be openly shared and that our goal is for data to be made open as possible. The restrictions that we put on data, the things that we check for, are inspired by the community. So if through this conversation over these days, we learn that there are additional checks and considerations that we should be considering around the release of sensitive information, we'll be very happy to discuss that. And that's all I'll say. Thank you.
Great, thank you so much. Next up for our panelists, we have Mike Imperiali. Mike, you can go ahead and unmute yourself and provide your 2-minute overview. Go ahead.
Thank you, Sarah. So I was asked to talk about how the American Society for Microbiology handles review of potentially concerning papers in publications in their journals. And so just to put this in context, I was an inaugural member of the NSABB, and I was involved in those discussions relating to the H5N1 transmissibility papers. And as an aside, I just want to mention, one of the things we forget is that the board originally recommended that the papers be published, but that the mutational information be withheld and used on only a need-to-know basis. And that was shot down by the journals, the authors, the NIH. And so I think that there are this issue needs to be revisited. So I just want to put that out there. So what we do at ASM is actually Arturo Castoval, who was also on NSABB, and I, after the H5N1 controversy, came back to the ASM and said, we need to put something in place to be able to review papers that may fall under this category of concern. And so the society put together a responsible publications committee. There's about 5 of us on the committee, and if a paper comes through and gets flagged, the committee will review the paper for DIRC or gain of function concerns. And the papers can get flagged in one of 2 ways. One is the review form has specific questions on it that are asked of reviewers as to whether, for the Journal of Virology, there are very specific questions relating to the 7 categories of experiments that are of concern. The other journals, it's more of a general question about, do these raise biosecurity concerns? And I'll come back to that in a minute. And so, if someone raises a concern, then the committee convenes and we discuss it. Sometimes we'll bring in the editor of that particular manuscript to, help inform the discussion. I can tell you that, the discussions have been very in depth. Sometimes they've been quite animated, depending on the paper. But I can also tell you that at the end of the day, and there have been about 20 now papers that the committee has reviewed over I guess now a 10-year period. All of these papers have been published. And what sometimes will happen is that the authors are asked to, tighten up the sections of their papers that talk about biosafety and biosecurity. But none of these papers have ever been rejected because of DIRC or gain of function concerns. But I have to tell you that I think the problem here is that the publication stage is way too late in the process in order to be able to try to put a stop on things. And there's a few reasons. Number one is, and I think Ken alluded to this earlier, most of the people who are doing this kind of review don't know really what the concerns are. Arturo and I, we're on NSABB and we spent 10 years talking about this stuff, but most of the people just don't know what those concerns are. So there's that. The second is, the question is, what happens if Journal X doesn't publish the paper? Are the authors just going to take it and shop it to Journal Y? And a little bit earlier, we talked about this concern that maybe some editors may not be paying attention. And I think a lot of editors are also not, educated, so to speak, in what the concerns are. So I think it's a very, very difficult system. And my view is that the publication stage is a little too late. And I think we also have to go back and revisit the issue of openness and whether, for example, NSD 189 is still valid in 2025. So I'll stop there. Thank you.
Great. Thanks so much. Our next panelist is Girish Patenge from the Chan Zuckerberg Initiative. Girish, go ahead and unmute yourself. Girish, are you here? Oh, hello. Wait, I see you now. Yeah, you seem to be on mute on your. Yeah, it's not letting him unmute. Is there, we're working on it in the room here. Yeah, perhaps while we, oh, are we good now?
Yes, can you hear me now?
Yes, we can. Go ahead.
Well, yeah, thanks, Sarah. Thanks for having me here. So I lead the AI infrastructure and information security teams here at CCI. To give you a sense of what we do here, we help researchers accelerate their research in order to help reach our goal of cure or manage all diseases by the end of the century. So that's the CCI's primary goal. And in 2023, we made a shift to focus on AI and building AI and funding AI models. So to help with this endeavor, we built our largest GPU cluster for scientific research, which has been put to great use so far. And earlier this year, we opened up our cluster to researchers who have GPU needs and are aligned to the work that we've already been working on. So, funding these grantees. And so think of this as giving out GPU grants. And we, in fact, had our first grantee come online last week. So, and we're not only funders, we're also builders ourselves. We're building a foundational model to represent a cell. And our virtual cell model is really, the idea behind it is to use to predict the behavior of healthy or diseased cells and accelerate the research in this field. We're also building a platform to host these models for folks who can't, run the models themselves. But today, I'm really representing the funder side here. And when we started this journey, obviously I'm new to this space, we're new to this space. So we're trying to figure out how should we think about biological risks? How should we think about the risk in these biological models? And we really didn't find a lot that was readily usable. So in fact, we started working with folks in this room, and we're currently in the process of building AI risk framework for biological foundational models. And the idea would be to apply that not only internally to our internal models, but also help our grantees assess the risk that they're seeing as they build their own models. The idea would be to mitigate the highest level of risks and reduce the barriers for the low risk models and just accelerate that research. The other thing that we're thinking about as a step after this is to really think about how can we level up the biosecurity knowledge across the community. So researchers really understanding the biosecurity aspects of what they're building. Researchers are really good at what they're doing, but how do we level them up in the biosecurity space? And what tools, what processes, what frameworks would they need to be able to do that, to be able to understand that, easy to follow? A lot of this to me is shared vocabulary, so that when we say this is a risky model, we mean the same thing across the board. So I'm really looking forward to seeing what comes out of this workshop. I'm really excited about this. I'm in a learning mode here, but happy to be here, and thanks for having me.
Great, thank you so much. It sounds all very useful. And our last panelist here is Richard Sever, right here. Go ahead, Richard.
Hi, so I'm Richard Sever. I'm the Assistant Director of Cold Spring Harbor Laboratory Press at Cold Spring Harbor in New York, and I'm also the co-founder of bioRxiv and medRxiv. So, I've been an editor for a long time, and so I'm familiar with the evaluation process that manuscripts go through, and started one clinical journal. And so we think about ethics, we think about the things you need to worry about that peer reviewers don't worry about, and how journals should be gatekeepers, for want of a better word, for information that perhaps should not be distributed. And of course, then it becomes a slightly different question when you come to a preprint server where you're not doing that thorough evaluation. But what we do at bioRxiv and medRxiv is we do screen papers. And one of the things that we think about is, could this material be dangerous? And so there is an escalation process. DIRC is something that we are concerned about. So we do things like contact Mike and Arturo, who Mike just mentioned, if we have concerns. So we need a process for knowing what is something we should worry about, what is the sort of thing that we should consult on. And beyond that, I think Mike pretty much said everything that I was going to say. So I'll leave it at that.
All right, great. All right. Thank you, everybody, all the panelists, for providing the very brief remarks to start. We're now going to start the actual session. So I hope that the panel will be lively and people will be able to talk to each other and build on each other's points. We're going to build on the breakout sessions that happened yesterday. So yesterday, all of the attendees addressed a series of questions, kind of collected into 3 overarching research themes. Breakout group 1 was molecules and proteins, 2 was systems biology and genetic cellular engineering, and 3 was epidemiological modeling and biosecurity. So in the breakout groups, after reviewing relevant outputs, outlets, and stakeholders for in silico research, we discussed what criteria might be used to assess and evaluate the research benefits and biosecurity risks in the context of DIRC and PEPP, in the context of that and existing guidance. And we also brainstormed on what additional criteria, if any, should be used to assess the biosecurity risks of that research, and including as relevant to each dissemination outlet. We also reviewed whether different dissemination outlets present different risks, and we finally shared challenges and gaps that still exist in assessing and evaluating the benefits and risks of disseminating in silico research in biological systems. So the way that we're going to structure this, we're going to hear input from each room as presented by one of our committee members that was participated in each group. And then the panelists will have an opportunity to react to those remarks and build on what they heard from their own views and perspectives. As we do this, I want to remind everybody to look at the Slido, where there's a link should be in the chat right now. You can put in your own ideas. For this session, we're using the Slido for ideas and solutions, and you can upvote ones that you think sound like a good idea. So as we last night and this morning, we, the committee, went through all of those Padlets from the breakout sessions yesterday and tried to collect some of the ideas. And we did see several key themes that emerged that seemed to be a little bit cross-cutting and certainly came up in each of the breakout sessions. So we're gonna, the first theme that we're gonna highlight, it has to do with prioritizing risks, or this idea of tiers of risk that might have different tiers of access. So for that issue, I want to call on Simone Bianco, one of our committee members who is in working group 3. So Simone, please go ahead.
Thank you, Sarah. My camera is on, just giving a second. Okay. All right, so, well, thank you. So Simone Bianco, Vice President of Research at Altos Labs. So I'm going to relay, I was in breakout room 3 on epidemiological modeling and biosecurity. I'm going to relay a few of the points that were prevalent in that discussion. I'm going to start with a quote. Security isn't about perfection, it's about friction and energy barriers. And so the point of discussions for the panel could be around what are the friction points and energy barriers that are easier to implement and monitor today, and which friction points are most likely to disappear with improving technology. The second point is also something that was made this morning. Historically, the computer science machine learning community is open by default, and really any mitigation that reduces the possibility of openly sharing will be faced with resistance. And so we would like the panel to comment on what kind of incentives can be provided to curb open sharing when relevant for biosecurity concerns. And I think, Sarah, you may repeat some of these for our panel. So I'm just going to go through all of them. I'm going to give you another quote that was made in our room yesterday. The strongest mitigation strategies should be limited to the most serious threats. However, and we've seen this with AI, will something that is not a serious threat become a serious threat when it suddenly becomes easy to make? And so this goes to the idea of, for example, AI accelerating some of these translation. And the last point that I want to relay is when something becomes openly available, that is irreversible. To what extent does a tiered approach address these problems? Back to you, Sarah.
Very good. Thank you so much. So that was a whole suite of questions that just came up. But yeah, I would welcome any of the panelists' reactions to any parts of that question, but just the overarching theme of being the sort of tiered approach, you know, to what extent can we implement tiered approaches that address risks, very serious risks, but also ones that are in between or less certain or are, where you would just want to create a little bit of friction, not withhold publication or anything like that. So any of the panelists who would like to start us off? Richard, go ahead in the room. Okay, then Jim after Richard.
Okay.
Oh, okay. I mean, I was just going to that point about this tension between open science and risk is I mean, a phrase that's often used is as open as possible, as closed as necessary. You use that with human data, for example, and I think that's something that we should be thinking about. And you can imagine coupling that concept to the point that Simone made about openness is irreversible. You can't close the door after the horse is bolted, but you can release something and then make incremental decisions as to how much further information you reveal where there are cautions. So the key is to have a system upstream that allows you to identify the things that you might worry about.
Yeah, Jim, go ahead.
Yeah, I was going to comment on the idea of sort of, yeah, this irreversibility of open availability of open release. So that's certainly true. And we think a lot about sort of tiered access approaches where we do this sort of step by step. I think in things like providing access to biodesign systems, it's very hard to do incremental access to those that either you have access to it or you don't. But I think we are a little skeptical about tiered release views, because once you provide any access to it to almost anyone, it tends to just be out there out of control. In today's environment, especially, and several speakers have made comments about this. Once anybody gets access to it, it's out of your control, and so it makes tiered release policies, I think, very difficult to implement effectively.
Great. Yeah, Mike, I see your hand up. Go ahead.
Yeah, so I'd like to talk about openness. So, I think that one of the things that we need to remember is that, and by the way, Simone mentioned, openness is the standard in the computational in silico field, but it's also been the standard in biology, right? I mean, the NIH does not fund classified research, and we're expected to publish in open access journals. So openness is there every place, right? But, these policies, and they've very much benefited mankind, right? The open sharing of data and everything like that, were developed at a different time, a different point in time. The world was very different then. The number of people who could do these kinds of things was very small. The number of places where this could be done was very small. Things were relatively expensive to do. But all of these factors have changed over time. And I think we need to now reconsider whether there ought to be this complete openness, or whether there are going to be certain types of data that need some sort of control. And, as Richard just mentioned, we control access to, human data. So why can't we also have some sort of controls over some other sorts of data? I don't know how this kind of system would work, but I think it's really worthy of more discussion.
Yeah, Jennifer, I see your hand up as well. Go ahead.
Thanks, Sarah. Richard said what's on my mind, as he often does. But what I want to pull on is this notion of changing our minds about what data we want to have out there over time. And I'm reminded of the question of retracted journal articles and all associated materials, and an ongoing discussion and a potential emerging standard for connecting objects through metadata. So right now, Dryad publishes data, and there may be associated research articles. A research article may be retracted. At the moment, we want the data to be available, but we also want to signal to the reader that that data is associated to a study that's been retracted. So we're talking about doing that through metadata. And since things, once they're open, they can't be unopened, could we use metadata to signal to the informed reader the state of appropriateness of the data once it's out there?
Yeah, that's a really great idea. There's been a lot of different ideas about use of metadata to include biosecurity information and what kinds of checks that sort of information has gone through, the use of a model, things like that. And I think that seems like a whole suite of potential options that could be explored more fully. Go ahead, Girish, but then we'll move to the next theme.
Thanks. Yeah, I was also in room 3 yesterday, and so this is kind of fresh in mind for me. And as we're thinking about funding our grantees, uh, we're not only trying to consider the risks that we currently see, but trying to project how these would be escalated in the future, like Michael was talking about, or Richard was talking about. A good example yesterday was 3D printers, and how the people creating 3D printers could not have imagined folks using it to print 3D guns, which is a very novel idea that there are going to be folks who do misuse it. The other thing that came to my mind is the portability of in silico stuff. And with the advent of GPUs just spread across the world, it is very easy to set up AI research across the world without and hiding it. It's much harder to hide a wet lab. So I think it's just something to keep in mind as we're going and thinking about these. When we're thinking about how we want to build our platform, we are thinking about this tiered access, but really thinking about it through how would this impact the research, and really not setting up too many friction points for researchers to jump through to try to get access to the things they need. So it's a fine balance that we're still trying to figure out our way through, and would love this community's help to do so.
Yeah, thanks. That to me, that harkens back to the wedge diagram that we showed earlier, that Alex showed, that had kind of the most research is in that green zone, and then it gets a little bit at the very tip. There's the very high risk things that we can mostly agree should be considered, and then there is a gray zone in between that is the most difficult part. The second theme that we wanted to bring up is actually going to be summarized by representatives from Group 1, and this is sort of a more concrete set of questions. So what would guidelines and practices look like? What should we care about? Who would decide and implement these things? What part of this sort of ecosystem of this community, what part of that ecosystem will have responsibility? So I'm going to turn it over to Valda and Jassy from Group 1. Valda, go ahead. Let me turn on your microphone.
Yeah, as we were in room 1, the molecules and proteins. And so I think, we talked a lot about what are the goals of guidelines and practices, and I think that goes to one of the slides Alex showed in his introduction today. We're into that, where what we really want to do is live in the sweet spot where we optimize sharing and minimize risk. And we also talked a lot about tiers, and when it gets to guidelines and practices, if you're going to have tiers, you'd have to operationalize your tiers. And to do that, do we need sort of if-then policies? There's a lot of discussion that we're moving away from the binary of is it DIRC, is it not DIRC, which would be, does not publish in a public journal, does publish in a published journal. And we're moving more towards this if-then, which is a lot more complicated. So maybe in one case, you would see in silico that directly enabled experiments that clearly were DIRC is one class. And then you would see maybe a model that can be combined with a data set to be risky would be something else, because it's not actually doing that in that research itself. So there are these different levels. And then we were thinking about this, we thought about this in the context of each of the stakeholders. So Jassy will go first with the...
Great. Yes, thank you. We wanted to quickly run through some of the main stakeholders that were raised during the breakouts, and a lot of our speakers have already touched on these. So starting with funders, we're now seeing that funders are establishing large programs for investing in AI-driven life sciences. So could funders, for example, develop tiered risk guidance for their researchers? They're in this unique position where they can potentially create incentives for responsible dissemination of work.
And then code and data repositories. I think Jen can speak to this much better than any of us, but they're the possibility of gating access, the possibility of monitoring for any kind of daisy chaining, of models and outputs. Maybe this needs automated tools. And of course, you need a funding mechanism if you're going to put responsibility at the level of repositories. And then the preprint servers, this is an early dissemination outlet with perhaps they do some risk assessment. So maybe preprints can be indicators that further risk assessment is needed before sort of broader, more open dissemination maybe. And then journals. Previously, journals were the gatekeepers to research, but really that's not the case. We can conduct risk assessment, but it, as Mike said, it now becomes one of the last steps in the dissemination process. So we really need the risk assessment to be occurring upstream. But it could still be that maybe the dissemination was not quite as broad upstream. And now as we go through, we're sort of inverting things to where we're, as the risk assessment is done, more can be disseminated.
Then two more main stakeholders. One is, of course, researchers themselves. And I think, Michael, you touched on this, that journals are no longer the gatekeepers to researchers in the modern day. And so perhaps researchers have more responsibility when they're making those decisions about disseminating their research code and data upstream of publication. If currently the default is that dissemination starts off broad and then gradually becomes more restricted during the publication process, do we perhaps need to flip that where dissemination starts off more limited and gradually becomes broader as the risks are assessed? And then finally, this stakeholder group of industry, which Sean mentioned earlier, industry research might never be published. It might have limited oversight or limited access to guidance regarding oversight. For example, some AI companies currently publish their research just as blog posts and never bother with the publication step. So what guidelines does industry need to create given this current ecosystem? So overall to the panel, and I'll hand it back to Sarah.
Yeah, so an overarching question, given all of those different stakeholders and some of the considerations we just heard, what practices do you think each of these groups need to develop? What is their role? How can they participate in building part of the solution here? Feel free to speak to whichever is most relevant. I feel like many of the ones that were just mentioned are directly represented here on the panel, which is very helpful. Jim, did I see your mic turn on?
Oh, yeah, I was just going to raise my hand too, but I'll just briefly comment on a couple of those things. Yeah, one is sort of in terms of sort of who sets our guidelines and so on. For my, I work at a national lab, and so we're basically working for the government in doing this. The policies and procedures that are set for us, like on safety and security that I mentioned, are set by the Department of Energy for the most part, then in response to things that flow down from places like OSTP and so on. So that it's a pretty clear environment on how these processes and rules get set for us. The funders do have a big part in this, of course. But I think when Jassy, I think, said, could the funders play a role in helping to set policy and so on around this, that just made me smile because my experience over many years working with funders is trying to get them to even say something about policy on product dissemination or anything is just like pulling teeth. So the fact is they generally don't know what to do in this, and they are looking to the research organizations and so on to help inform them in doing this. And I think that's really our job, and that's the only way this will be coherent, is if we are feeding back to them. And then they do play a very important sort of gatekeeping or maybe friction point role in this as well. But I don't think we look at the funders as sort of the source for that, really. Okay, over.
Yeah, well, this sort of gets to the point, this sort of cross-sectoral sort of question. A set of guidelines that might be policy at a national lab that could be seen as, best practices in another context and just, good practice by a researcher evaluating their own work, for example. But those dissemination patterns are complex, and it speaks to kind of the cultural challenge of, using somebody else's, guidelines that were developed in a way you might not understand or have transparency for. But there's others on the panel here that have raised their hand. Jennifer, you've been patient. Thank you. Go ahead.
Thank you. A few thoughts from me. So technically, with respect to controlling access and setting levels of access, that's straightforward. That's no big deal. In terms of who should be enlisted in making this happen and where the responsibility lies, not with the guidelines, but with the implementation, I'd like to register a strong vote against sitting it with the researcher. I speak from the perspective of trying to advance open science for the last 20 years, and we've been most effective where we can provide support and service to the researchers in realizing our open science strategies. That's certainly true at Dryad, but it's true elsewhere as well. So I would advocate for supports and systems to support researchers to do this and not make it their responsibility or their focus, and that can be done farther upstream as well. So with the kind of expansion of support for data sharing, we are seeing more institutions get involved too. So just for example, Dryad has a long relationship with the society journals and publishers where we capture data at the end of the process, right? If not at publication, at submission. But of course, for many reasons, we want the data much, much earlier. And that's true for some of the policies coming out of the United States. And so thus, with the universities in the US, we see the data curation network coming. So the institutions adding resource to support the researchers to organize their data in a way that's appropriate for sharing way ahead of submitting the story for consideration at a journal. So that to me signals an opportunity to involve that community. And I'll stop there and let my colleagues jump in.
Great, thanks. Girish, go ahead, and then Richard.
Yeah, thanks. Jennifer, I'd love to kind of riff off of what you just said about researchers. So kind of for us as being both the builders and the funders, we have kind of a dual role here. But I'm glad Jim's smiling that we're planning on enforcing kind of this risk analysis at the onset of our funding journey. So as the applications are coming in, we're thinking about how to do this risk analysis. But what I've started to notice is the researchers who are building these AI models specifically have the most knowledge about what they're building. It's really hard for us to think about the risks without their help. So how do you kind of balance that? But what is also not clear to me is, do the researchers have the right training, the right tools, the right skill set to even assess this? So it feels like we need to arm the researchers with the right knowledge and information and skills and tools, but at the same time still rely on them to make some of the discoveries of risk that might not be obvious to us.
Yeah. Sorry. All right. Yeah, Richard, if you want to participate, then we'll get to Mike.
Yeah, I will echo a couple of points that were made earlier. I remember being at one of those NSA BB meetings, and Mike, you may have been at the same one, where there was questions about what we would do at bioRxiv about some of these things, and my response was like, if it's down to us to be your gatekeepers, then you're doing it all wrong. This is far too late in the process. And I think it sort of speaks to the idea of really having joined up thinking and understanding the research chain from the point at which a decision is made to do something, to fund it, to execute the research. And there are, again, there is analogies in the medical space with registration of research. So if you have a situation where it is the person who really knows that there may be some risk when they're embarking upon it, and the funder is incentivized to really understand the things that they're funding and not just say, well, it's somebody else's problem. And then by the time you do get to a point of dissemination, be it Jennifer at Dreyer, be it us at bioRxiv, or a journal, something comes with some kind of level of registration, and you're like, okay, this is something we need to be concerned about, so that you know from the outset that it's something that you should be looking at.
Yeah. Yeah, thanks, Richard. Go ahead, Mike.
Yeah, so I want to come back to this issue of the responsibility of researchers. So I think that, as Jennifer noted, right, the researcher is the expert in terms of what they're doing, and they, should know what the implications of their work are going to be. Now, of course, as researchers, we're all in here with that positive attitude, right? I'm trying to benefit, mankind, or, plant science, or whatever it is, by doing this research that I'm doing. But I think that researchers also have a responsibility to be aware of what some of the risks are. And this comes to what Girish said, right? Where I think, researchers just don't know. And I'll give you an example, and it's a personal one. Until I joined the NSABB, I had no idea that there was a biological weapons convention that prohibited the use of bioweapons. And since that time, whenever I give a talk about, biosecurity, biosafety things, I would start the talk off by saying, how many of you have ever heard of the BWC? And I'll tell you, it's like 1 or 2%. And this is, anywhere from students up to, senior PIs. And so that's just one example of where, I think researchers are not aware of the risks, right? And so I think that we need to do a better job there. I know that some institutions have tried to incorporate this into responsible conduct of research training, but I'm not convinced, that really kind of, sets in. And so I think what I'm saying is we need to still ask researchers to think about these things. I think some of us in this room were at the 50th anniversary of the Asilomar conference a few weeks ago. And one of the ideas that came up there is that, maybe each lab should do a little bit of red teaming when they're, coming up with an idea and trying to set up an experiment, or, develop an AI model or whatever it is, and do a little bit of red teaming to see, what can come out of that. So I think there are ways to do that at that level. And then the final thing I wanted to say with respect to stakeholders in general is, I think we have to remember that, we're not going to be able to put a block here or a block there. And we really need to adopt, and this is not my idea, it's nothing new, a Swiss cheese model, right? Where we put, as many, sort of bottlenecks as we can into the system, so that hopefully something won't slip through at the end.
Yeah. Yeah, that's very good points about sort of the culture and trying to move the life sciences community and the researcher community in particular, move them into a state where they can participate more in these discussions, because there's a lot of uncertainty about these things. I'm going to move to the final theme, which is about future proofing. So we just raised some of the uncertainties that we were just talking about in Silico stuff. There's uncertainties about the actual capabilities of the models. To what extent can they really design something that might be, harmful? To what extent, could those harmful designs be turned into biological reality? There's just like uncertainties stacked on top of each other. And then when you're trying to project out into the future, and how those different things are going to change over time, and the different capabilities will change over time, that discussion becomes really it sort of compounds that problem. So the final question, the final theme that we're going to raise here is about future proofing. For that, I'm going to hand it to my colleague and committee member, Phelim McGowan from Group 2. Go ahead, Phelim.
Thanks, Sarah, and thanks to all the panelists for taking part. So, as one of the topics discussed in our group yesterday was future-proofing. That if we make guidelines only for today, we might in effect be frogs in boiling water, unable to react to developments that arise at faster and faster pace. And that perhaps instead, or in addition, we need to think about where the capabilities are going and make plans for how we should deal with those capabilities. We could set tripwires now using, if-then guidelines and so on, curated by experts, as has been touched on in some of the previous questions and discussion, so that we're prepared for future advancements. Another potential longer-term approach is to incentivize the instilling of a culture of risk assessment, risk-benefit analysis, encouraging researchers and authors to consider and share risk-benefit analyses before dissemination rather than after. And I think, Michael, you were just talking about this a little bit in terms of red teams, for example, that instilling this culture of risk analysis might be potentially quite important because the act of dissemination, particularly dissemination of the capability, like sharing the model, is irreversible and global, as been talked about already. And because applying checkpoints on, say, specific dissemination outlets may just lead to the use of alternative dissemination pathways. So we need to be encouraging people to do it sooner. So to the panel, how best can we plan for the future and not just for today? I'll pass it back to Sarah.
Right. As our panelists think through that question, I'm going to remind everyone to look at the Slido, and if you've come up with a perfect solution to these complex problems, please leave it there. You can also upvote suggestions or ideas from other people. Among our panelists, who would like to go first about future proofing? All right, Mike Imperiali, go ahead.
So I'll dive in. So yeah, I'm always reminded of the famous quote from Yogi Berra, right? That predictions are hard, especially about the future. And we're in that situation now, right? So that's really tough. But anyway, I think there are two things here. I think the first thing that we have to remember that in terms of sort of something that's timeless is ethical behavior, right? And I'm not sure that, again, we do a really good job when we're teaching science, training scientists at higher levels in instilling the need to be ethical in our behavior. I think we all assume maybe we've learned that as kids or something like that, but I think it's worth reinforcing in the context of what we are doing. So that's the first thing. And I think the other thing that we have to also somehow, get into people's heads is a sense of humility, right? That we, the scientists, don't always know everything that's right. And we have to be willing to listen to others who, do have concerns and may see things a little bit different than we are. So I think it's these two sort of broader characteristics than, just day-to-day operations of research that we need to keep in mind.
Right. Yeah, thanks. To me, in addition to that kind of like training or cultural inculcation, if we can call it that, it would be beneficial both now and into the future and can help us keep track of those things. I'm thinking also that in some of my own thoughts would just be that whatever we decide today is not going to be the end all be all. And even if we can find a full consensus on a perfect set of guidelines, for this thing, which we are not even attempting to do in this process. But even if we could, we would need to be revisited probably in 6 months and 6 months after that. And it's going to be an ongoing process in any case.
I would just echo what Mike said, because I actually think this is something the scientific community has been pretty bad at, placing in training, putting things in historical context. We do see, we see this in genetics, where a lot of people who work in genetics are really unfamiliar with some of the history of that field. And there's, in the clinical space as well, there's a pretty terrible history of some experimentation in that space. And I think, we could be a little more humble and have everybody learn a bit more about that and apply those lessons going forward, and so that we don't make the same mistakes with this technology.
Yeah, one question I want to ask more specifically, Jennifer, just a sec. One thing that's particular to this particular question about publishing and dissemination is that the dissemination pathways may change over time as well. And so I'm wondering, how we can think about that in terms of this future proofing question. But Jennifer, go ahead.
Thanks, Sarah. I like the suggestion from the group that we focus on a culture change and developing a culture of risk sensitivity, if not also humility, because we can't guess what's going to happen tomorrow, and we can really tie ourselves up into a pretzel trying to figure it out. So, rather than future cast, think about here and now. What can we change here and now? And it resonates with me very much, the notion that we could get the brains working on this work to think about it for themselves and to future cast and to that, future cast from the ground where they're doing the work and to think about the risks and the benefits. And to that, I would just tag on that to see the type of change in behavior that we want, we would need to incentivize people for doing that.
Yeah, do you have suggestions for how to incentivize? I mean, when I talk to, broader communities about incentives, for good behavior, a lot of people say, well, make the publishers require it because publication is such an incentive in this community. But obviously we're hearing it from all sides now that, somebody, should develop these incentives for that. And I'm wondering if anyone has suggestions there. I'm glad the funder has raised his hand to go ahead, Girish.
Yeah, because we have seen this in cybersecurity as well. It's where it's not the incentives, I think, are like, can we make the default behavior risk, to take into account the risks? So it's changing how people think about it. So, when you build, SaaS apps or whatnot these days, you do think about data privacy a lot more. You do think about cybersecurity and things like that. So having that at the fundamental level and having researchers just be knowledgeable about it, give them the tools is really the way to change that culture. So I'm just thinking about how do we instill that at all layers and have what I found, which I mentioned earlier, is I found that folks say risk, but they mean different things when they, when they mark the tiers and other things. So how do we get to a common understanding? Because that leads to a lot of confusion and a lot of misunderstanding. So, having a shared understanding amongst the community would be the first step. Doing baby steps, just like Jennifer was talking about, like getting them to do it now would build that muscle memory, would instill that kind of process within their research. So like as you're going through the research, you're starting to take notes on like, okay, this might be risky, and really put that together as they go farther down. So all of these things, I do think we need a more concerted effort to do it. I'm happy to help as a funder to help start this process, but it has to be really a community effort.
Yeah, Girish, what you said just reminded me of yesterday. I believe it was James Diggins who talked about the need for more shared vocabulary when talking about enabling technologies and risk. And we just don't. It's very difficult to have conversations because one person's head goes to 11 when you talk about risk, and somebody else says, "Oh no, we just mean this very tiniest step up in risk." And it's very. We don't have good language for that. Certainly not that crosses kind of sectoral divides. Jennifer, go ahead.
I would pull on the incentives question again, if I may, unless you want to move to a different area. So my perspective is from publishing and research communication. And Girish, it's interesting that you said that it's kind of we want to take the lead from the community because it's this ping pong game, isn't it? Between what do the funders want, what are the funders going to get us to do, and what will researchers kind of abide. And my own view from the publishing space is that folks need credit. They need academic credit, something to put on their resume to get recognized for. And I think Richard invoked the rich registered report process where maybe this is something we could think about, that a risk analysis framework needs to be registered with someone. I'm not sure, the funder, the institution, the preprint server before the research itself can go out. And then in that case, we would want to extend credit for the publication of that risk register until the world changes and the publication record isn't the be all end all for people's career advancement.
Great, thanks. We're actually getting to the end of this panel, so I want to just invite any of the panelists who have any final thoughts to weigh in now before we wrap it up and go to our final breakout sessions where we're going to really try to come up with solutions and ideas here. Are we all set? All right. In that case, I will call this panel to a close. Thank you all so much for your thoughtful contributions. And it was a really great panel, I thought, that really touched on multiple different parts of this ecosystem. So we really appreciate your contributions. We're going to now go into the final breakout session. I know that Yes, I know that I have not yet looked at the Slido, but I'm hoping that it has all of the best ideas there that we can use as a basis for our breakout in the next session. For now, I'm going to turn it over to our committee member, Hector Garcia Barton, who will introduce what we will do in the final group activity for this workshop.
Thank you. Welcome to session 9. I'm Hector Garcia Martin. I'm a staff scientist at the Lawrence Berkeley National Lab and Director for Data Science and Modeling at the Joint Bioenergy Institute, Biofuels and Bioproducts Division. The focus of this session, session 9, is to discuss and refine collaborative policy options, norms, guidance, strategies, and or best practices for safeguarding the research benefits and advances, while at the same time reducing the risks posed by disseminating in silico research. When considering these proposed strategies and practices, we ask that you focus on who, how, and particularly when. This will ensure that your input and ultimately what will go into the final report can be implemented. All groups will answer the same question. What approaches or strategies should be used to promote high-quality science, scientific progress, and the openness of science while mitigating the biosecurity risks associated with disseminating in silico research in biological systems? As they answer this overarching question, the group will aim to highlight priority areas for guidance and policy development, propose next steps for implementation and collaboration, and identify key stakeholders for follow-up actions or engagement. To collect answers, the group will be using a new paddle, just like yesterday. The links will be shared in the rooms. For people in the room, if you do not have a computer, we will have note takers to help input your thoughts. The breakout groups are not recorded, and any information shared in these rooms will not be attributed in the final report. By joining the breakout rooms, you agree to abide by the Chatham House rules, where I quote, "Participants are free to use the information received, but neither the identity nor the affiliation of the speakers nor that of any other participant may be revealed." For the in-person attendees, we have 3 physical rooms on the second floor. You can join any of the rooms. Be mindful to not all go into the same room, please. The NASM staff will help direct you to the rooms. Online attendees will be randomly assigned to one of the 3 rooms. You will all have a microphone and camera access in these rooms. And with this, we will not take the 15 minutes break, and the breakout rooms will be open in 15 minutes. Thank you.
So we're gonna have to go downstairs, but.
Hey, everybody, just hang tight for me for a second while we get everyone back from the breakout rooms and into the main session. We should be getting going in the next couple of minutes, so just stick around.
Okay, the break is over. Now we are going to go into a very short report out. I hope that all the breakout discussion were productive and that you were able to condense or at least summarize what you've heard. So in these few minutes, and I'm going to pick a room, if you remember your room number, randomly for starting, you are going to expose, and I encourage everybody to reflect in the room if you have anything to add on those strategies, and especially focusing on who, how, and when. Will be really the assignment here. So I'm going to start with room 208. Yeah.
Oh, I guess that was us. Yes, we had a good discussion in room 208, and we have a very well-populated Padlet, which we can check on. A couple of the things that we talked about in some detail. One was this idea of pre-registration of in silico research. That would include some kind of check or discussion about these kinds of risks. And then the big questions though came up, whereas like with whom, with what kind of body would you pre-register your research? It could be some external body. There was a lot of discussion about institutional bodies, kind of similar to an experimental or wet lab research registration, which is common among many or most, if not all, institutions in the US. Even research on the wet lab side that is very, very low risk, or, BSL-1 generally does go through some, checklist style registration process, and we could require something similar for in silico research. There's another question under that bucket of questions about incentives. Why would they do that? What are the requirements there? What is that? Could there be funding requirements? Could there be publication requirements? There were ideas, about, liability, but it was not clear what, how you would implement, increased liability. And also concerns that trying to raise liability in that institutional context might just make institutions less likely to participate in any of that research, which would be a downfall of that kind of idea. The other sort of big category of things, or one of the big categories of things, is that we talked about was a need to be very precise and to better understand risk levels, because not all risks are the same, and people need to have more resources to actually do risk benefit analyses. And one of the things that we talked about was that we could start with these kind of oversight ideas with the biggest risks, the things that are the most consensus building. For example, in silico models that are tightly linked with actual DIRC and PEP research, or even in silico resources and databases that come out of DIRC and PEP, like actual research, which would be a good place to start in first of all, actually reducing risks and helping us think through how these things could undergo some oversight and what kinds of mitigations we might want to look for in that context. But it could also provide a basis for bringing the in silico work kind of into the fold of any oversight, in which case you could start to have the discussion about what else, should you look for in silico models. Are you part of DIRC PEP research? Like, yes, then you can go through that gate. But if not, you can start to have other conversations about what kinds of risks you might be interested in, what kinds of mitigations might be appropriate. But if you start with that most risky, most consensus-based end of that spectrum, that can really inform a lot about how you pursue the oversight for the entirety of that kind of research. So it implies a whole theory of change about how you could get from here to there. So that was a lot of what we talked about. One of the things that came up, I think, in multiple spots here is that we need things that really work for the researchers, which is one reason we talked about these sort of institutional, these close-in kinds of oversight mechanisms, because those might be the things that researchers could most easily engage with. But I think I think that captures what we've got. But I'd be happy to hear from anybody else in my group that thought there was an important point that was not captured in my summary.
Any additional thoughts on the group? So we can go to the group number 2 that I'm going to pick 206. And if there is some commonalities that you had in your group discussion, just highlight them and then build on or add to it. So we don't, but it's important to know if you also had a similar question, because it means it's important.
Okay, great. So I'll do the readout from room 206, and some of it does overlap with what we just heard. Our first thought or recommendation of what we really wanted to see was an effort to identify a narrowly focused highest risk tier of the most concerning work with associated thresholds and clear responsibilities, as well as practical risk mitigations that are all outlined. Ultimately, it would be useful to create multiple risk tiers, but we thought that focus on the highest risk would would help us make progress on this difficult problem. So then the question is, well, how do we do this? We were thinking to establish the risk tier, it would be useful to establish an authoritative working group that's really fully laser focused on identifying what this work is. This working group should draw on any existing frameworks that might already exist, for example, in the CUI or classified community, or ones that are currently being developed, such as by funders, as we heard earlier. And then after this is developed, it would be useful to communicate the framework to researchers. So we would like to see it turned into a curriculum and a biosecurity training program that could be disseminated to computational biologists, AI scientists, and other researchers that are conducting the work. One fourth recommendation was that we wanted to recognize the importance that data plays, not just models. So thinking about curated databases that could help advance AI research, but that also have secure infrastructure and managed access built in. And then finally, one thing on our wish list was an authoritative advisory group that could respond to cases that come up. We called this our free biosecurity consultation service that would provide unified guidance as concerns arose, as compared to an ad hoc approach where people disagree, some kind of unified and authoritative group. Those were our thoughts.
Thank you. Anything to add in this group or reactions?
Yeah,
Yes.
I'll just say that we also in our group mentioned the idea of, like training, and perhaps that kind of training could be kind of like the ethics training and other things that are already required by federal funding. Although, there are downsides to that. And people also pointed out that senior researchers would need that training as well. So it would not just be, kind of a incoming grad student sort of thing, but that kind of training was something that was discussed in our group as well.
Thank you. And the last group.
Speak for our group. There are three areas that we kind of came into consensus on sharing. One of the first ones was technology gaps. So when we think about what would be the ability to advance really good quality research quickly at the same time mitigating risk, one of the questions that came up with is, what do we need? These could be things like automation. It could be also things like what are the robust processes to manage the concerns, like having an advisory council. So that was kept broad. But it was a question that I think we need to characterize in more depth to list like the one or two or three key technologies that are the gaps between where we are right now and where we could be. The scale is very big and very broad in what we're discussing, and it runs across the biological scale, also across scales of models. So to be able to identify where 99% of low risk things are and what are high risk, as mentioned before, is a good exercise, and to manage the low and high risk with different types of rubrics. And then the last thing I think was touched on, if we have a council, is there also a shared ethical framework that everyone who's training in the domain of biosciences and in AI would be able to adhere to, at least within the ecosystem of the US. Three, please go ahead.
No, any reaction? Oh, okay. With 5 minutes to go, right on time, I'm gonna ask Alex and Valda to close this meeting.
All right, well, so thank you very much. So this has been a wonderful meeting, and I'm going to let Valda give most of the thank you. So I want to make just two closing points. The first is I want to mention that the deadline for implementing the new DIRC and PEP policy guidance for physical research is rapidly approaching. And as you may remember, in silico research isn't currently covered in that policy. So we hope that the feedback that you've provided, that we've given here, the conversation we've had today, and that the report that we generate will help to inform the process of considering how those guidelines should be extended into the in silico space. We will continue to write up our findings. That will take some time. So while we do that, we welcome the opportunity to engage further with stakeholders from US government, industry, academia, civil society, and so on. I do want to just take my prerogative to give a special thanks to the National Academies for asking a philosopher ethicist to co-chair this committee. I think we've heard today about the importance of a deeper engagement with ethicists about some of the novel issues here that aren't off the shelf related to risk and the challenges of creating policies that reconcile a host of important social values, from open science that fosters replication and interoperability, and the importance of expeditiously managing relevant biosecurity risks. And so I look forward to deepening that conversation between my science colleagues and our humanities partners. And then I'll let Valda close us out.
Thanks, Stu, for the opportunity of serving on this committee. And it has just been so amazing to be on a committee with such diverse expertise and backgrounds. And so it's been a real interesting learning experience. So thank you. And then, of course, thanks to our sponsors for enabling this fascinating workshop. I think we really got some productive work done. Thanks to our speakers. You know, we asked all the speakers to speak in pretty short time slots. They all did it, and they achieved the goal of really setting the stage and catalyzing the discussion, which is exactly what we had hoped for. And so they helped to facilitate a really interactive workshop. But mostly that interaction was thanks to our very engaged online and in-person participants. So thanks to all of you for really coming and taking part. That was great. And finally, thanks to the National Academy of Medicine staff who really put this all together. And I think I said it yesterday, but I'll say it again. I have not been in a hybrid meeting that worked this well ever before. So where you really felt as if the online component was part of the meeting. And so thank you. That was really good. And thanks, Audrey.
Okay, I'm going to take that last minute for 29. This committee has worked every single week since November. We met every week, so thank you so much. And we hope to have a proceedings out of this activity around the June timeframe, June-July timeframe. But like Alex mentioned, we encourage any interactions that you want to have with us or suggestions. So you have our email address. And with that, I'm going to adjourn the meeting.